Work to stretch a spring. Spring has a constant K of 20 newtons per meter. Okay, I'm good with that. The amount of work required to stretch the spring from equilibrium is modeled as work equals integral of f of x dx. Yep, that seems reasonable. Where f of x is negative kx. Work is measured in joules. Yes, it is often measured in joules, which is Newton meters. I think it's Newton meters. Find the magnitude of the work required to stretch the spring to 3 meters from equilibrium. Okay, so they give us this work equation right here, and we're just going to plug in f of x. So at this point, zero level of deep thinking. Our thinking is the equivalent of the kiddie pool at this point. So work equals integral. Ooh, that was very smooth. Negative k. Nah, that's a terrible k. Kx dx. And I just took f of x, plugged it into the equation. And now I'm going to simplify things. So from equilibrium, I'm going to assume that's 0. And we're going to 3 meters. Find the magnitude of the work required to spring from 3 meters from equilibrium. And I'm going to move the negative out. Actually, I'm going to move the equal sign slightly. I know, terrible boardmanship. You're not supposed to write things on a whiteboard that a student can't write on their paper. So copying and pasting is kind of frowned upon, or the whole select and move to the side. That's okay. You guys don't care. You don't care. But I'll pretend that you do. You don't. Okay, and then, so we just have this equation, and we just take the integral. Yep, I think we just solve it from this point. So we have negative 20 x squared over 2, because the integral of x is x squared over 2, power rule. So negative 10, 3 squared is 9, minus 0 squared, which is 0, and I took the 2 and moved it over. And we have negative 90? But it says magnitude, so the negative sign's irrelevant. So 90, and then it'd be measured in joules, which is Newton meters. Which makes sense because K is measured in newtons per meter. So newtons per meter, X is measured in newtons. So we basically have newtons on the inside equation. Then we integrate with respect to X. It gives us Newton meters. So let's see if 90 is a possible answer. It is. Haha. Huzzah. And none of these are negative because it's asking for the magnitude. Though potentially 0 is negative. I don't know. Is 0 negative? I have to Google this real quick. Wait, one. So I guess according to the Google, 0 is neither negative nor positive. That's why some people will use the term non-negative to basically mean positive. The more you know, and knowing is half the battle. All right, that's how you do work to stretch a spring.